Hello everyone, I'm Daryl Heath with UA Little Rock's College of Arts, Letters, and Sciences. Welcome to the night sky. With the arrival of spring, stargazers bid farewell to the wintertime constellations of Taurus, Orion, and Gemini, and say hello to new arrivals such as Leo, Virgo, and Boötes. But it's more than just a changing of the guard. Our whole view of the universe changes as well. During winter and summer, the sky overhead offers us views of the inside of our Milky Way galaxy. But in spring and fall, the night sky is a window looking outside the galactic plane and into regions of space beyond the galaxy. Spring is a great opportunity to see dozens of different galaxies and galaxy clusters. But what if you don't own a large telescope? Are there still cool things to see? The answer, of course, is yes. With just a pair of binoculars or a small backyard telescope, say anywhere from 2 inches to 6 inches of aperture, there are always a great many things that one can see no matter what time of the year. In this episode of The Night Sky, I want to offer the beginner stargazer who doesn't yet happen to own a large telescope or who only has a pair of binoculars the opportunity to get outside under a dark sky and see a few amazing things on their own. I've selected 4 deep sky objects, some suited for binoculars and some that are perhaps more suitable for a modest-sized backyard telescope. Now, what do I mean by deep sky objects? Simply put, these are celestial objects that are located outside of our own solar system, objects such as star clusters, nebulae, and even other galaxies. If you don't have a telescope of your own, be sure and check with your local library to see if they offer loaner scopes. Many public libraries around the country currently do so. To see if there are any libraries in your area that offer these kinds of programs, just go to librarytelescopes.org. Your local astronomy club might also offer loaner scopes or binoculars. If not, I bet that they offer star parties you might attend so that you can look through various types and sizes of telescopes in order to see some of the objects that I'll be talking about. To find out where the closest astronomy club is to you, just pay a visit to either the NASA Night Sky website or the Astronomical League. Okay, if you're ready, let's get outside on a dark, moonless spring night and begin our sky tour. In today's technological world, many of us are familiar with GPS and a variety of different digital assistants that can help us to navigate to a specific location when we're traveling. There are similar kinds of computer technology that can guide our telescopes across the sky in order to help us navigate our way around the heavens. But not all of us can afford these kinds of things. A common method that many astronomers have used for ages is known as star hopping. Star hopping is nothing more than using familiar celestial signposts to help guide us to more challenging objects. An easy example would be using the 2 bright stars that make up the front end of the bowl of the Big Dipper in order to guide your eyes to the rather faint North Star Polaris. The apparent distance between the stars as we see them upon the sky is usually measured off in angular degrees. For example, if you draw a line from those 2 bowl stars, Merak and Dubhe, and the Big Dipper, you have traced out a line of about 5 degrees. If you extend a line from Dubhe to Polaris, you've now gone approximately 30 degrees. A useful way to measure the sky is literally right at your fingertips. If you make a fist and extend it out to arm's length and then hold it up to the sky, the distance across your fist is about 10 degrees. Extend your pinky finger out and hold it up to the sky. The width across your pinky is 1 degree. Extend your 3 middle fingers out and you're now measuring 5 degrees upon the sky. The distance between your extended pinky and your index finger is 15 degrees, while the distance between your pinky and your thumb will measure off 25 degrees. I mentioned earlier how the spring sky is full of galaxies for the owner of large telescopes, but that doesn't mean that there aren't any available to those of us who own binoculars or small telescopes. On any clear dark night, and from as dark a sky locale as you can manage, go outside and face north to find the Big Dipper. Next, locate the star Phecda, sometimes known as FAD, which makes up the lower left corner of the Dipper's bowl. Extend a line from Phecda towards Dubhe, the star that forms the upper right corner of the bowl. From Dubhe, continue that line out to about 7 degrees. With a pair of binoculars, slowly scan around this part of the sky. You're looking for a relatively bright smudge of light. When you find it, you have found Bode's galaxy, also known as Messier 81 or just M81. This is a good place to stop for a reality check. Galaxies and nebulae are never going to appear as the bright, colorful photographs that you see on the internet or in magazines. The human eye simply cannot absorb the number of photons that a camera can with a long exposure photograph. Instead of expectations of Hubble-like images, just keep in mind that when you look through the eyepiece at these various deep sky objects, that the light hitting your eye has traveled across vast oceans of both time and space before finally being absorbed by the retina in your eye. In that sense, you are physically interacting with an object that is located thousands or even millions of light years away. While Messier 81 is going to appear as a bright oval-shaped smudge of light in binoculars and small telescopes, it is in fact a grand spiral galaxy that is some 90,000 light years across and located about 12 million light years away from Earth. Like many spiral-shaped galaxies, M81 has a high concentration of stars at its core. The combined glow from all of these stars is what creates the bright nucleus that you are seeing in your binoculars or telescope. And while you cannot see the spiral arms, you can detect their presence in the form of the soft glow that creates the halo around the brighter core. It's in the spiral arms that all of the galaxy's gas and dust is to be found, the stuff from which stars are born. Stars are scattered throughout the arms of the galaxy's disk, and it is their combined light that creates the feeble glow of the halo. The galaxy was first discovered in 1774 by the German astronomer Johann Bode. Bode also discovered another galaxy right next to M81, and you can see it as well within the same field of view of your binoculars or in a telescope with a low-power eyepiece. How's that? You get not one, but two galaxies for the price of one. The second galaxy is known as Messier 82, or the Cigar Galaxy. Rather than having an oval shape like M81, M82 is more spindle or cigar-shaped. The reason for this is that we are seeing the galaxy edge on, as opposed to M81 with its nearly face-on view. As a consequence, M82 appears a bit dimmer than its companion. Both M81 and M82 are interacting gravitationally with one another, and at some point in the past, they must have had a very close encounter where the gravity of M81 strongly distorted M82. This encounter also triggered a burst of star formation inside M82. Moving right along, we're now going to look for the famous Whirlpool Galaxy, Messier 51, in the constellation of Canes Venatici. It's pretty easy to find, but because it has such an overall low surface brightness, you really need dark skies with no moon to see it. Just go to the star Alkaid, the star that denotes the end of the handle of the Big Dipper. About 2 degrees below the handle of the Dipper, you'll find a fourth magnitude star known as 24 Canum Venaticorum. 2 degrees to the right of Canum Venaticorum, and you'll find a smudge of light that is M51. You can see the smudge in binoculars that magnify 10 times, but in a small telescope, things start to get really interesting. With 3 inches or 4 inches of aperture, you can see the galaxy as an oval-shaped disk with a bright nucleus at the center. But hold on, what's this? Is that a faint tendril of light reaching out from the oval towards a smaller oval? Yes, it is. That smaller oval is a tiny compact galaxy known as NGC 5195, and that tendril is a stream of material that's being ripped away from M51 by NGC 5195. Over the next few hundreds of millions of years, the two galaxies will collide and fully merge with one another. Interestingly, the Hubble Space Telescope was able to image the core of M51, and the photograph reveals a curious-looking cross-shaped mark where the supermassive black hole in this galaxy resides. Astronomers believe that the dark part of the X marks where a 100 light-year diameter ring of dust, seen edge on, is obscuring our view to the black hole's accretion disk. Just an additional cool thing to think about when observing M51. Now let's move on from the interesting smudges of light to some very nice eye candy. We're looking for an open cluster of stars located in the constellation of Cancer, known as the Beehive, or Messier 44. Open star clusters are loose gatherings of stars that were all born from the same cloud of gas and dust and are more or less bound to one another by their mutual gravity. The cluster is somewhat dim, as are the stars that make up the constellation of Cancer. So we're going to use some bright stars from two other constellations to guide us to it. Find the stars of Gemini, Castor and Pollux. Castor is the star that's on the right or west, and Pollux is the star on the left or east. Now, once you've found these two stars, I want you to locate the bright star Regulus, the brightest star in the constellation of Leo, and which is located east of Gemini. If you draw an imaginary line from Pollux to Regulus, then the beehive is located about halfway in between the two. With binoculars of any size, this seemingly empty patch of sky suddenly blazes forth with dozens of bright stars shining like diamonds in the dark. Most are white in color, but you'll also see a few that appear red or orange. What's up with those? Well, those are higher mass stars that are reaching the end of their lives. They've depleted their fuel supply of hydrogen in their cores and have now swollen in size to become red giants. Upon the sky, the beehive cluster spans 1.5 degrees across. That's the same diameter as 3 full moons placed side by side. All told, there are some 1,000 stars swarming around inside the beehive, and their estimated distance from our own solar system is somewhere around 520 to 610 light years away, and are about 15 light years across. While the beehive is a fine example of an open cluster, a somewhat loose grouping of stars that are bound to one another by gravity, there's a more compact type of grouping of stars known as a globular cluster. Globular clusters are massive, compact clusters that contain thousands or even millions of individual stars, their mutual gravity having pulled the group into a spherical shape. Our last object on this tour is a very fine example of a globular cluster, and it's known as Messier 3, located in the constellation of Canes Venatici. To find M3, just go outside on a dark spring night and face the northern half of the sky. We're looking for the bright orange star Arcturus, fifth brightest star in the night sky, and located in the constellation of Boötes, the herdsman. Use the Big Dipper and the mnemonic Arc to Arcturus. All you have to do is extend the curve of the Big Dipper's handle out in an imaginary line for about 25 or 30 degrees until you run into this bright orange star. Next, we need to return to the Big Dipper and look under its handle for the small constellation of Canes Venatici, the hunting dogs of Boötes. The brightest star of Canes Venatici is Cor Caroli. Draw another imaginary line from Cor Caroli to Arcturus. Messier 3 is located about halfway along this line. Use binoculars to first locate it as a fuzzy-looking star upon the sky. Binocular views of M3 will reveal it as a softly glowing cotton ball of light, brighter towards the center than it is out upon the fringes. You'll need a telescope of at least 4 inches or 6 inches of aperture before you can begin to resolve individual stars, but it's a splendid sight in any size telescope. While you might see hundreds of individual stars in M3, astronomers estimate that there could be more than 500,000 of them crammed within a sphere that spread across some 200 light years. Like many other globular clusters, M3 is very, very old. Current estimates place Messier 3 at around 10 billion years old, almost as old as the universe itself. Okay, that's all for now. But before I go, if you're looking for a good book to help you find some relatively easy targets upon the sky, I'm going to recommend that you get a copy of 100 Things to See in the Night Sky by Dean Regas, astronomer at the Cincinnati Observatory and co-host of the syndicated show Stargazers on PBS. Be sure to check out our own Night Sky website each month, where we feature a calendar of monthly highlights as well as articles on specific celestial objects for you to observe either naked eye or with binoculars or a small telescope. Clear skies to you all, and make sure that you take a little bit of time to step outside and look up in both awe and wonder.